we're trying to get the kids to do in this lesson is we're trying to get them to relate fractions to division. That's one of the biggest things that, I want the kids to see is there's a reason why there's a numerator and a denominator and that it relates to the operation of division. Drum roll. If I said, all right, I got candy bars, who wants some? First of all, raise your hand if you want some candy. I'm surprised, I didn't know you want candy. All right, hands down. What would be the problem, though, if I have these two big candy bars and I'm trying to hand them out to all of my friends? What's the biggest issue? Stephanie?
You won't be able to give people equal amounts.
You won't be able to give people equal amounts? Caleb?
You only have 2 Hershey bars.
Hey, I have 2 Hershey bars. Raise your hand if you've ever been in this situation before. You've got like 3 pizzas, 5 friends. I say you got a problem, right? Do we agree? Okay. So first of all, here's what I want you to do before we get started. I want you to discuss with your group, what do you think we can do to pass out this candy? Go for it. We started off with adding and subtracting fractions with unlike denominators, that type of thing. Now we're moving into the the first part of lesson 2. What we're trying to get the kids to start with is now taking a whole number and another whole number and dividing them and seeing that it turns into a fraction. Eventually we're going to start having them move on to understand how to change the improper fraction back to a regular fraction. What do we come up with? What are certain things that we could do to pass out this candy?
Well, we could divide the number of people, the number of the little squares that are able to be broken off on the bar by the amount of people there are.
They're going to have the 2 big pieces of chocolate, and I know a lot of them are just going to say, well, why can't we just break it apart? Or I think another one, I do have some students who may go to the next level because I am going to tell them these are 2 5-pound chocolate bars, which is obviously going to be the attention getter. I think one of the big things is the kids who do make that connection between the weight and the fractions are then going to even say, well, I wonder how much each of the fractions would weigh.
I made 3 pieces and then divided them into 4s, and I was gonna split them into equal parts, so each person would have gotten 3/4 of.
How did you know to decide them to just divide them into 4s like that?
There were 4 people and 3 candy bars, so I divided them into 4s.
Does anybody in the group agree or disagree? Or? What did you do, Brendan?
I made 3 bars and split them up into 4 parts. And then took a 1, a 2, a 3, and a 4 for each of the parts.
So you decided to number off your pieces? And you decided to number off yours? How do I know in yours who gets what piece?
Oh, I was gonna label them.
You're going to label them as well? All right.
First, I did
Uh-huh.
after I knew what I should get, and I was gonna draw it out.
So you decided to use the numbers first and then draw it. Okay.
Are we supposed to show that how many people get what?
Exactly what she did. Look, we cut it into 4s and then label it like 1, 2, 1, 2, 3, 4.
I did A, B, C, D, like person A, person B, person C, person D.
Okay.
I noticed some of your pieces, some of them are really skinny and some of them are really fat. So if I was sharing this and it was you and me and we had some candy, which piece do you think that you're going to pick? You're probably going to want that one, right? Yeah. So, I think the biggest thing is the students are more used to the standard algorithms. They really want to do, I could show it to them 1/2 times 2/3, and they'll go, oh, that's easy. They're multiplying the top and the bottom, numerator and denominator, but they're not quite understanding the conceptual part of it. I think the biggest thing is trying to get them to understand you can justify, show me how you did it, with pictures as well. I think that can be a little new for them. They've worked with the fraction bars. They've worked with all types of visual models prior to 5th grade. It's just some of them get caught up on, well, I already know how to do that this way, but making that connection, I think, sometimes can be a little new for them. So here's what we've decided. If I take, what was it, 3 pieces of chocolate, and I divide it amongst 4 people, everybody gets 3 pieces of chocolate. Do we agree? Yes. So I have my candy bars back here, and I have 2 candy bars. If you all are saying each person gets 2 candy bars, do they get the full thing? No. So I'm a little confused. A lot of us are saying you get 3 pieces of chocolate. So you get 3 full pieces of chocolate. I started off with 3, and I divide them among 4 people, and I get 3 pieces of chocolate. Some people caught on. Discuss with your group what's the problem. The biggest thing we did was we work a lot in pairs. My room changes a lot. Sometimes we're just in partners with 2 desks paired together. Many times we're in pods. One of the biggest things we worked on was how do we work in groups. That's something we are kind of struggling with. They're great kids, very smart. I do have a lot of kids, though, who are, I like to call Batman. Everybody wants to be Batman. Everybody wants to be the leader. We're trying to work more on collaboration and say, well, yes, I agreed with you when you said this. However, I think this. So we've been doing a lot of activities where some of them it's kind of almost painful. Like I have to listen to this person, even though I don't 100% agree. And we've kind of been working on when is a good spot to jump in with your opinion, when is a good time to listen and to have, understand there's value in what the other person is saying. Then I want you and your group to start filling out the paper because it is asking us to draw a diagram to show your process. Go for it.
Are we gonna put why we put 3? Why we cut it into 3?
Why are we going to do
Yes.
I multiplied 6 times 4 to see how many together I would have. And then I did 24 divided by 6 to find out how much I should give each person. And then I drew my diagram.
Whereas I drew 4 boxes. And there's 6 people. So on the bottom I did the factors of 6, and I did the factors of 4. And then I got 12. So then there's 6 people, so I split each candy bar in half, and another half in half, and the other half in half. Then there's 6 pieces, so the one person will get 4 pieces.
Okay, any challenges? So I have a few challenges out here, okay? Stephanie, what are you challenging?
Why do you put the factors of 6 and 4 below the box? Why did you do that?
Because I was trying to see what number would make it get equally, so 6. So the 6, 12, 18, and so on and so forth, and 4 and 12, and the person that are equal to each other 12.
Any other challenges? Jackson?
First of all, she didn't write how much there was, and she said each person got 4 pieces instead of saying she got 4/6 of a piece.
I think quite honestly, I probably would only pick maybe 3 problems to just really stick on and hammer home. I think as we started to work through, I noticed that the concept was much deeper. I knew it was a deep concept, and I think sometimes with the kids, when you have to readjust, you say, I thought that we could move at a little bit quicker pace, or I thought they would understand certain concepts of it, but I did notice that, it might have been a little too much.
Me and my group wrote 1 6 plus 1 6 1. Well, we wrote this because after you're done writing your diagram, each person gets 4 6 from the 4 candy bars. So they would get 1 6 from each candy bar. So we wrote 1 6 plus 1 6 plus 1 6 plus 1 6 equals 4 6 because they would get 1 6 from each candy bar in order for them to get break it into equal amounts.
Sebastian, what do you challenge?
I think that is kind of right, but only after you knew that it was all divided into 6.
Why do you say that, Sebastian?
Because when you just start the problem, you don't know that each person gets 1 6 from each candy bar. I say that because I also used the last problem, and when it shows the answer, it also used a small number getting divided by a big number.
To have other kids make a face and say, oh, well, yeah, that's exactly what it is. I knew that, but I didn't say it. It really makes you feel good as a teacher. Not only just to say, hey, this is what I taught them and I understand that they get it. It's great to now have them express it to me in a way. It makes them sound like little adults. But it's a great feeling.